we have to talk about the injector pressure control sensor. It's a 3-wire pressure sensor, reports the pressure in the high pressure oil pump, or on the right common rail in later versions. Here it is on the later versions on the left fender cover, and on the early versions it's right on the back of the high pressure oil pump. It's a 3-wire sensor sending the signal here. It has 5 volts in ground, the usual things. You must have voltage reference and signal return. They're shared with other sensors, as you can see with the dotted line here. You need to make sure that all this 3-wire sensor checks the way it normally checks. Fairly simple to check. But let's talk about the normal readings. Here's what the readings look like. Key on, engine off, does not start at 0, goes up to slightly more than 4 volts, which in this case is for an early model, that's right around 3,000 psi. The later version goes to 4,000 psi, and we've talked about those. It can cause a variety of symptoms, ranging from stalling, hesitation, extended crank, and surging. And again, a quick way to check to see if the pressure sensor is working properly is to disconnect the pressure sensor. We've defaulted to our 725, 750 for PSI, which is above the 500 minimum to start to fire and run the injectors. So if the vehicle starts with the ICP disconnected and will not start with it connected, the ICP is at fault. It's a quick test. Here's this location back here we've been talking about before. If you think it's not measuring correctly, as we said earlier, you can go in here and measure it with a 5,000 psi gauge, but be careful. This is high pressure oil. You could cause damage. Next, we're going to go into looking at data for the scan tool and how to tie the scan tool data for the ICP and the pressure regulator all together. Now we need to take some time to see how the IPR and the ICP work together. My way to remember this is PR is pressure regulator and CP is control pressure. It's a sensor. The IPR is controlled by the PCM. It's going to control the pressure in the high pressure oil system based on the measurements made by the control pressure sensor. It's going to report the pressure back to the PCM, and then we're going to make the changes. So let's look at it. We've got the 2 sides of our heads, the left heads and right heads going out of here. Our ICP is measuring pressure there in the center. And our regulator down here at the bottom is going to be regulating pressure, which controls the amount of oil we let back into the drain that goes back to the reservoir. Now our IPR is going to try to contain pressure between 450 minimum up to 4,000 psi. High pressure, getting to the 3 or 4,000, that's going to take a 100% duty cycle. If you see now, the IPR has gone out and completely covered the drain, so none of the oil is going back. The max pressure from the IPC, HPOP, high pressure oil pump, is going out to the 2 heads. If we go to 0 duty cycle, we have low pressure, we're letting all the fluid go back to the reservoir. Here is our bidirectional control we can use. One of these things about a good thing here, we've selected the injector control pressure regulator, and it opens up and says pick the duty cycle. Right now we're picking 80%. We're going to run a test here to see if we can get maximum pressure. We'll go look at some more scan data later on and see what it looks like when the vehicle's actually operating. So here we are. We've taken our ICP. We're going to be sure that this edge filter doesn't get clogged up. We should have gotten rid of all the sludge before we got here. In a few cases, you might find this guy plugged up. Now, here's our test. If the IPC controls the outlet pressure in the range of 437, bare minimum, up to around 3 or 4,000, different by model years, we should be able to get the car started. Now, what we're going to do is we're going to check for a crank and no start. We're going to start with the ignition on, with the key engine off. We're going to monitor the control pressure sensor. If this pressure sensor voltage is not between 0.15 and 0.35 volts with ignition on, we need to test the pressure sensor. If the engine does not start, then we disconnect the ICP, attempt to start the engine. If the engine starts, this indicates the ICP is defective and needs further testing. It's going to automatically substitute about 700 to 750. We say now only 725 PSI is a default sensor if the ICP is disconnected. So if the engine does not start and the ICP is disconnected, we need to go start and look at some other things. We need to look at fuel pressure. We need to look at the high pressure oil system. Remember, both fuel pressure and high pressure oil can keep us from starting. Either one can be a problem. So here we are looking at our data on our ICP. High pressure oil pressure must be at least 500 psi to start and open the injector. Now Ford says 434. There's a lot of specs. We prefer, and most technicians prefer 500. Look what we have in this particular case here. We've got 0.8 volts. We've got over that. We got 0.86. We're running 23% control pressure regulator duty cycle. Our desired control pressure is 585. Our actual is 585. We got exactly what we asked for. The computer has seen and corrected and has exactly what it needs. If you have a no start now, it is not a result of low oil pressure. Let me say that again. If you have a no start now, it is not a result of low oil pressure. Remember, we've got a number of things that contribute to a no start. Fuel injector control module, the FICM, has got to fire the injector. Fuel must be supplied to the injectors to be injected. So you've got those two other issues to worry with. We've eliminated one of them with this test. Now we're going to look at the ICP and IPR for diagnostics. As we said, if we're cranking and we're 54 to 85% duty cycle, right now we're only 23 up here in the scan data. So you can see how far we are from 54 to 25. And the ICP is low but steady. Either the pump is bad or we have a gross leak. It's really bad. Either one. But if 54 to 85, the ICP is low and the readings jump around, the pump is bad or there's a high pressure oil leak. We can't be sure of which. Both could look the same. Very likely it's a high pressure oil leak. Here's what happens. When we move up to 0.85 volts, we're running 583 psi, and we're only running 24% duty cycle on the pressure regulator. If we move up, we get 25.39%. We go to 622 psi. So you can see only 1 or 2% moves voltage quite steadily. And we're going to put some other stuff up here we're going to be looking at. Here we're at 44%, 44.9. We're up at 1,354 psi. Now we've gone and put some more data up here so we can see some additional things. Now we're running 60%, slightly over halfway, a little above 50, 2,825 psi. That's 3.4 volts. Now looking down a ways, the control pressure desired is 2808. We're running 2805. We're running 3,868 RPM right now. So we're running a high RPM. But look, we're asking for 2,800 psi. We're getting 2,800 psi. We're getting what we asked for. So that readings look good. You get a feel now for what your scan data and your pressure regulator and your duty cycle all work together to tell you what's going on with your oil flow. Again, this doesn't tell us we're getting good fuel. We can still have fuel problems. We can still have FICM problems not driving the injectors, but it's not an oil problem at this point. Here's our readings for our injector control pressure sensor. These are PSIs on the left column and the voltages on the right columns. 0 is our 0.17 to 0.32. When we crank, we want to see at least 0.8. That is pretty much universal. Now, we do get some leaking IPRs. It's in a pretty hot area. We get some oil. We get it hot. A lot of people recommend replacing the pigtail that plugs into this. It's a short harness made to be replaced. Here's the Ford part number. This 5C3Z part number will get you the component to replace this when you have to fix the IPR, the regulator. You might want to put new O-rings on it, put a new screen in the front, and put this pigtail on the back because it takes quite a bit of abuse. Let's talk about high pressure oil leaks. If a high pressure oil system is creating the required pressure, but the engine won't start or exhibits extended crank times, there's a possibility of the leaking off before it gets to the injector. We need to be sure of that. Could be, but it's unlikely. If there isn't a restriction on the outlet side, the pressure will be lower than normal. Any pressure on the outlet side will reduce the restriction. So here we go. If we got a leak, the high pressure oil system leaks, we're going to have these symptoms. It starts cold but not hot. We've had a few that will start hot but not cold, but they're rare when we have these leaks and cracks. Cracks seem to always be the ones that you fall outside of this general rule that start hot but not cold. But most of the leaks, like O-rings and stuff, usually start cold but not hot. We have extended cranking, hard starting, no matter which one it is, stalls and won't restart, low ICP pressure when cranking, telling us we can't get enough pressure to open the injectors. We've already gone over how to look for this. We're tying all this together. To check the high oil pressure, you're going to need to supply shop air to do and pressurize the high pressure system. So let's stop and talk about how we would pressurize this system and check it in a unique way where we take control and we're the supplier of the air pressure.